If a 6 by 3 matrix A has rank 3, find dimension of null A, dimension of row A, and rank of A transpose. So rank is 3. So we know the relationship between rank and dimension of column space and row space. So what is that? Dimension of column A is same as dimension of row A, and this common value is rank of A. And when we have a matrix M by N matrix, that means N many columns. Okay, so we got N columns. So rank A, so rank A plus dimension of null A is equal to number of columns. So if we have N many columns, then the sum of these two numbers is N. Okay, so in this case we got rank 3, so this is 3, so number of columns is 3, so that's the number of columns 3, rank is 3. Then what is dimension of null A? So this is 3, okay, this is 3, and N is also 3, so this must be 0. Okay, and what is dimension of row A? I mean, dimension of row A is same as what? Rank A. So rank 3, so this is also 3. And rank of AT, rank of A is same as rank of AT, A transpose. So this is also 3. This is same as rank A, which is 3. Okay. In number 2, we have a, suppose a 5 by 6 matrix A has 4 pivot columns. So pivot columns means you can think like the rank, because the rank is coming from pivot columns, and these are coming from free variables, non-pivot columns, and total number of columns. So we got 6 here, 4 pivot columns, so you can think like rank A is 4. So what is the dimension of null A? So there are 6 columns, 4 pivot columns, so 2 non-pivot columns. So dimension of null A is 2. Is column A R4? Okay, the rank is 4, so rank A is 4 means dimension of row A is 4, dimension of column A is 4. But if you look at this matrix column A, we need to figure out where column A lives on. Okay, so we have 5 by 6 matrix means here is 5 R5 and here is R6. Okay, so let me write here, this is R5, and we have a linear transformation. So that's how we get 5 by 6, it's backward. 5 by 6 matrix. And column A lives in this space. So column A is in fact a subset of R5. So about R4, no, I mean there is no mention of this one because column A is in R5. So each vector has 5 components. So it's no, because column A is in where? R5. That means each column has 5 entries, so R4 is not even the case. Okay. Number 3, if the null space of 7 by 6 matrix is 5 dimensional. Okay, so dimension of null A is 5. So we got number of columns 6. So dimension of null A means non-pivot columns 5. Then how many columns left? 1 more, right? So dimension of column space, that would be just 1. I mean this is rank in fact, which is 1. Dimension of column space is number of pivot columns. So we got 5 non-pivot null space. Dimension of null space means the number of non-pivot columns. So 5 out of 6, so 1 left. So the answer is 1. Number 4. If the null space of 5 by 6 matrix is 4-dimensional. So we got total number of columns 6, and null space means that's the non-pivot. Okay, dimension of null A is 4. So non-pivot columns 4. So what is the dimension of row space? In fact, this is same as previous question. Dimension of column space is same as dimension of row space, and that common value is called rank. So there are 4 non-pivot columns. Then how many left now? So null space means non-pivot columns. Okay, there are 4 non-pivot columns. That means 2 pivot columns. So dimension of column space is 2, and that's the rank, which is same as dimension of row space. So dimension of row space is 2, which is in fact rank A, which is in fact dimension of column A, and which is in fact comes from number of pivot columns. And the null space comes from number of non-pivot columns. So we got 6 columns here. Number 5. If A is a 4 by 3 matrix, what is the largest possible dimension of row space of A? So row space of A, dimension of row space means it's the rank A, which is same as dimension of column space or dimension of row space. In fact, these two questions are same. If A is a 3 by 4 matrix, what is the largest possible dimension of row space of A? Dimension of row space is same as dimension of column space, which is called rank. So if you look at closely, so we cannot have 4 because there are only 3 columns here, or in this case we have only 3 rows. So the largest possible dimension in both cases is 3. Okay, that's the maximum possible of rank of A. It cannot be 4 because we have only 3 columns here. That gives us the dimension of column space, or in this case dimension of row space. Okay, that's the max. Okay, max for both answers, for both parts, in fact 3. Number 6. If A is a 6 by 4 matrix, what is the smallest possible dimension of null A? So dimension of null A, smallest possible. Okay, so 6 by 4 matrix means this is number of columns. Dimension of null A, so we know that rank A plus dimension of null A is total number of columns. In this question, 4. Okay, and this rank is coming from pivot columns. This is coming from non-pivot columns. So in 6 by 4, so that's the case. So what is the possible dimension of null A? And in fact, look at 6. This is 6, so number of rows, the row space can be at most 6, but there is a 4, so it will be at most 4. So this 4 is smaller than 6, so rank A could be 4. Okay, rank A could be 4. So in this case, if the rank A is already 4, the maximum, we don't know, but the maximum could be 4. In that case, 4 equals 4, so this could be 0. So the smallest is 0. Okay, this could be 4 because 6 by 4, 4 is smaller than 6, so it's possible to have rank up to 4. We cannot have rank 5 or 6, by the way. I mean, rank could be 0, that's fine. Rank could be 1, 2, 3, 4. The at most rank could be 4. So when this is 4, the maximum, then the minimum is 0. Okay, number 7. Could a 6 by 9 matrix have a two-dimensional null space? Okay, let's look at here. 6 by 9, 6 is smaller, so the rank A, so maximum rank is 6. Okay, that means maximum rank A means 6, means maximum pivot columns is 6. Then there are how many columns here? 9. Out of 9, maximum pivot columns is 6. So that means minimum, when we got 6 pivot columns is 9, that means minimum non-pivot columns is, we have to go all the way to 9, so 6. Sorry, 6 so 9 means 3. My bad. So total is 9. So maximum pivot columns, maximum rank is 6, sorry, because there is a 6. Maximum rank is 6, that means maximum pivot columns is 6. So minimum non-pivot columns will be 3. So that gives us dimension of null A. So the minimum, so dimension of null A is always bigger than or equal to 3. The minimum is 3. It could be 4, 5, 6 all the way to 6. Okay, because that's the 6 is the case. So minimum is 3. Then could that matrix have a two-dimensional null space? No, because the minimum non-pivot columns are 3. That means minimum dimension of null A is 3. Okay, because the maximum pivot columns is 6. So the answer is no because of this.